The topic of this episode is the rapid growth of supermassive black holes revealed. Our universe is thought to have originated about 13.8 billion years ago from a hot, dense state. As it expanded and cooled over time, it created a hierarchy of celestial objects that have evolved into what we see today. Considering the evolution of the universe, it started with no stars or galaxies. Over time, the first stars and galaxies began to form. Therefore, it is believed that black holes did not exist at the very beginning of the universe. However, in our nearby universe, we observe the presence of supermassive black holes, such as those seen in M87. Many galaxies contain supermassive black holes at their centers, which shine brightly and are known as quasars. Given that the universe has a beginning, understanding how quasars with such massive black holes formed is one of the greatest mysteries of cosmology. This diagram represents a schematic view of black hole growth. The horizontal axis shows the mass of the black hole, and the vertical axis shows redshift, which indicates the age of the universe. To the right, the black holes are heavier, and upwards, the universe is younger. The diagram includes observed data and several models of black hole growth. Quasars are located in the lower right section of the diagram. Recent observations with the James Webb Space Telescope have discovered massive black holes in the distant universe. The areas where the James Webb Space Telescope cannot observe are indicated by the blue hatched regions. Although data is still lacking and we don't fully understand how supermassive black holes have grown, the most plausible scenarios involve growing black holes from seeds formed in the early universe through two processes. The first is the process of accretion, where a black hole grows by accumulating surrounding matter. The diagram shows several accretion models, noted as times Eddington. Considering accretion alone, a seed black hole of about 100 times the mass of the Sun, which could have formed from the first stars, would not be sufficient to create the supermassive black holes observed in the nearby universe in a reasonable time frame. It seems necessary for the seed to be around 100,000 times the mass of the Sun. The second process involves merging black holes to form even more massive ones. The exact ratio of these two processes is unknown, but it is thought that a combination of both has led to the formation of supermassive black holes. To observationally confirm these growth processes, it is necessary to identify celestial objects at each growth stage that match theoretical models. There is a hypothesis that quasar formation is triggered by the merger of gas-rich galaxies. According to this scenario, gas-rich galaxies merge, explosive star formation occurs in dust-covered galaxies, and a dust-covered quasar is formed. This quasar then generates outflows that blow away the surrounding dust, resulting in a bright quasar. Dust absorbs visible light, making it difficult to detect objects in the pre-quasar stage, which is covered in dust. Recently, an efficient method for exploring pre-quasar objects covered in dust has been proposed. This method involves searching for objects that are dark in visible light but bright in mid-infrared. Mid-infrared observations are conducted using the WISE satellite launched by NASA. The WISE satellite has a relatively small 40 cm diameter telescope compared to the latest James Webb Space Telescope, but it can survey the entire sky. Thus, WISE can observe many bright objects buried in dust, and combining this with highly sensitive visible light data allows for testing the aforementioned hypothesis. No data currently exists for highly sensitive all-sky visible light observations, so some dusty pre-quasar objects, corresponding to hypotheses 2 and 3, have been discovered in specific regions. These objects, deeply buried in dust, are considered to be dusty galaxies and are named dust-obscured galaxies, DOGs. However, the pre-quasar outflow stage objects, which are rarer, have not been found due to the limited visible light search range. Thus, it is clear that without highly sensitive and wide-field visible light observations, testing the hypothesis is challenging. The solution to this problem comes from the Subaru telescope, which is a proud achievement of Japan. The Subaru telescope's greatest feature is its much wider field of view compared to other 10-meter class ground-based telescopes, the upcoming 30-meter telescopes, and the latest James Webb Space Telescope. This feature is enhanced by the Hyper-Supreme Cam, HSC, which can capture an area of 1.7 square degrees, equivalent to 9 full moons, at once. HSC is a massive camera with 116 CCD sensors, totaling 870 million pixels, allowing for highly sensitive surveys of large sky areas. Since 2014, a large survey project has been carried out, investing 5 years and 300 nights of observation. A research team led by Dr. Noboriguchi from Shinshu University, Japan combined visible light data from the Subaru telescope with mid-infrared data from WISE to search for objects that are dark in visible light but bright in mid-infrared. As a result, they discovered 571 dogs in the universe about 10 to 11 billion light-years away. Furthermore, the team also investigated objects at the stage where dust is being blown away by outflows. They focused on one characteristic of quasars, their blue color in visible light. It was previously believed that objects covered in dust appeared red, but the team hypothesized that objects in the transition stage to quasars would start to shine blue. They explored this hypothesis and identified 8 blue glowing objects, naming them blue excess dogs, or bulldogs. The research team also conducted spectroscopic observations to confirm if the blue light truly matches the light from quasars. The diagram shows spectra with wavelength on the horizontal axis and brightness on the vertical axis. Blue represents the average spectrum of objects in the pre-quasar stage, and red represents the spectrum of quasars. The comparison revealed spectra similar to quasars, capturing signs of outward gas flows from the centers of galaxies. These observations confirm that the blue glowing, dust-covered galaxies are in a transitional stage evolving into quasars. The research team noticed that extremely red objects discovered by the James Webb Space Telescope in the early universe, around 12 to 13 billion years ago, resemble the characteristics of the blue glowing dusty galaxies. This implies that quasar formation was already underway in the early universe, about 13 billion years ago. However, there are differences upon closer inspection. For example, the diagram shows the mass and luminosity of black holes in 2 objects. The dusty blue galaxies have heavier and brighter black holes, suggesting differences in outflow occurrence and scale. Since the number of such blue glowing dusty galaxies is still small, increasing the sample size and conducting detailed spectroscopic observations are expected to clarify these differences and similarities. Future developments in this area are eagerly anticipated. Thank you for watching, and I'll see you in the next video. If you enjoyed this video, please don't forget to give it a thumbs up. Hit the subscribe button and the notification bell icon, so you'll be notified when new videos are released.